Hello, anonymous. So till now we have watched a lot of videos on AI. We didn't do much of brainstorming, or we can say analysis or practice on these topics. So we'll do that now. We will read things and um, we will code on maybe in Jupyter notebook. Okay, and yeah, we'll see. Before that, just want to inform. I was reading about. I was actually watching a video of Andres Karpathy. So he's a quite familiar person in the field of AI, and he has an amazing video, 3 hour 30 minutes video. So which explains everything about ChatGPT in a high level. Um, not for the coding part, but for the architecture and how things work. So I got to know some amazing things there. Like um, there are four stages. First is pre-training, then tokenization, then neural network training, then inference. Okay, so pre-training refers to like collecting a data. So data should be useful data. I mean to say high quality data. Okay, so selecting a high quality data is a big thing. Then filtering out mm, things like uh, not acceptable, like some kind of adult things or some kind of violence related things. So these are removed, and then we get proper data. There are some websites that he explained that he showed that have a good amount of data. So this data is need will be fed into the language model. So before that there is a tokenization part. So whatever the data is there, so it is converted into as we know, it will be converted into um, um, some it will there will be some conversion, and it will be converted to binary values. So binary values is and then but binary values are large. So what we have tokens. Okay, so tokens are uh, so they are distributed into tokens. So not sure how many bytes in one token, but there are 100,277 um, symbols possible in one token. So there are different symbols, and these many symbols are possible in single token. Okay, so all the data is converted into tokens. We have a model. It will train, it will give output in terms of tokens, and then tokens are again converted back to words. Okay, so whatever the training that we are doing for the data is on the tokens. So the language model has to produce tokens, and then that we are converting into words. So the first part is pre-training, second part is tokenization, and third part is neural network training. Neural network training, there is um, we take a sequence of tokens. uh, we define a max number of tokens that we want to feed into the system at a time. A neural network will be having a large mathematical expression, and as we know, basic neural network. So each parameter, uh, each input have some weight. So so there are weights, and that is parameters. and that parameters we need to train, and then once and then it will give output. Okay, so there are multiple possible things, and then it will see uh, like there are, suppose as I told, 100,000 and 277 possible tokens. So maybe one of the token is having a higher probability for, and that token will be taken as a output. And inference, what it will do, it will take the input sequence in the backward direction. I mean, it will take the it will use the input to train, to see whether the output it is getting is correct or not. Then it will generate the data or predict the data. Okay, so there are few papers that it is suggested to read. So for GPT-2 language models are unsupervised multitask learner. This paper is there. And then we learned about base models. So what is base model? Base model is actually all this data is trained um using a basic language, using LLM, and we have like base model have they are trained like it has 4 billion parameters and trained on 15 trillion tokens. This is Llama 3 by Google. So this is base model. This is the basic training over the data that it is there, and it doesn't give a very comprehensive output, uh, or a very personalized output um, for the input that we provide. So it is a base model. Okay, so we can just say like it is a internet document simulator. Okay, so this is kind of whenever we are making a new model, language model, so it is kind of base. So the language model will get input from this to get some to find inference from that data. Okay, so this is the thing. And once base model is there, like earlier GPT-2, which is a little old, so it had 1.6 billion parameters, and it was trained on 100 billion tokens. So that is fine. And thing is, we can't make language model, sorry, base models at home. Like these are done by big tech companies, and it takes like maybe around 2-3 months, and very maybe thousands of GPUs. So this is um, very costly affair, and we try to avoid this. We can't do actually. And we whatever we make a model, so we train on the base model. Okay, so and how we train, it is actually I was quite uh, what to say, I was quite cornered when I knew that okay, I used to think like okay, this language ChatGPT is there, so whenever I'm searching, it has some kind of excitement. It shows okay, yeah, yeah, do you have any other queries, let me know. Or oh, if I say like um mm, ChatGPT, thanks for this result, or thanks for this mm, whatever you have done, so it will give a very good answer, like no, no, it's just my part, or something very humble or something. I was quite, and this language actually changes with different language models. So if I see in Grok AI, so XAI, that is Grok, so I see like their language is much better actually. And if you see maybe Meta AI or something else, I didn't see, but they have a different language. So I used to think like, okay, what causes this? I mean, uh, how is it decided? So uh, I was quite taken aback that these are actually, there are lots of questions that are fed by human, and human labeler only will provide the answers. Okay, so it's like maybe 100,000 or millions of questions and answers, like what is the top 5 place to visit in France or Paris. So this their output is given by the labeler, and this your mm, your model, your GPT model or your whatever LLM, try to uh, emulate that your labeler actually. So it is not actually like it is having a personality. So this personality actually comes from that labeler, and human labeler are quite intelligent, I mean quite knowledgeable person, and they try to keep their answers out of bias, because that is required, um, since they are emulating this or simulating this. So and this chat GPT will provide a very similar answers. So very many examples is so like okay, mm, there is one, he took like 20 20 words of a Wikipedia document. He just pasted in the base model, okay, and just pressed for the output, so it showed the output exactly same. This he gave the complete document, whatever, I mean it's complete whatever lines, all lines of this Wikipedia. It should give something different, but it gave exactly same. So it shows that they are memorizing things. Not sure they are intelligent or not, but they are good at memorizing and maybe accumulating things. So so AI is not a magic thing. It's actually um, getting. I'm not sure how to what extent it is learning, but at least kind of we can say a rote learning kind of approach is there. So um, a rote learning method is the one that is they are following. Okay, so few more things like what I got like okay, if I want a baby GPT, suppose this will be used maybe. Okay, so we will put an audio device uh, in this children's room or group. We will get a lot of questions and answers from the children, or maybe one child. Okay, and we will train our language model over that, and that GPT, or sorry, that language model will try to emulate your child. Okay, and maybe sometimes their answers will, you will quite surprised that okay, and maybe you use this, there are many audio models also, we use that thing, and you see like okay, this is my child only saying, because it is there his thought process, and it is his or her voice. So it is quite astonishing, like there are thousands of um, exciting applications that I can think of, And even though we don't reach to AGI, that is artificial general intelligence, which seems quite far, or maybe there is other breakthrough is required, because current one is just learning from whatever data is provided, and it is quite blind to what it doesn't know. So it is quite blind, it can't explore the thing. So maybe some breakthrough in unsupervised learning will give a quite a breakthrough moment in that. So we should be excited to that. But currently this language models are not going to give AGI. Rather, there are thousands of applications, small applications, big applications, and maybe robotic AI. Still, I don't see this language model working well. So, if robotic AI that can be done with the supervised training, so they can, with human data, so um, they can actually uh, be a really useful robotic intelligence. So if we train our models, some good models, not sure which one, so that thing will actually work it, right? Okay. So this language model is actually um, we train them based on maybe human joints, how it moves, and we try to emulate the same in the robot. So it is able to use their actuators and sensors based on that. Mm, and if it is able to do it, see, it doesn't require AGI for that. It should learn by supervised learning. It should have some general uh, intelligence, which it can get through um, the input that we provide, and that is enough to do quite a lot of things with robotic intelligence. Okay. Obviously, new research or new domain is not in the reach of current AI. So still there are a lot of things that can be done. Just a second, I want my camera to be full. So I know this source. Yeah. Some stuck parties era. Frame per second should I increase? Disable now. So okay, let it go. I don't want to let it be. So coming back to my course, I had some points to read and then some some points to understand and then some code to write. Okay. So first thing first. Okay. Okay. Let it be. Leave it here and sign up later. Once to few things. Okay, let me have my own Jupyter notebook. I have some command to go to this partner. Few things. I'll write basic code. I'll write input variables. I will write I'll have to, after the input and output, I'll shape and size things considering, and then what we have, we will have. So first thing, mm, math, then few more things I think. Not sure. The code, right? No, I have this thing. No? This thing. Okay. I'll use this as an inspiration. Okay. I have to complete calculation here. So what we're using for loop. Now we don't need to use. We have some other things, and anyway, this was for linear regression. Now what we are doing? Now we are doing logistic regression. That is sigmoid function. Okay. So let us begin. Let this closed. Okay. Now, now what is there? Uh, let's consider there are three input variable. Okay. So what we will have? We will have maybe x1, x2, x3. Okay. We have So x1, x2, x3. Okay, and then we have kind of, let's say, 5 training data sets. Okay, so what we have, we consider, so we will have a separate thing. Okay, we will combine them later onward. So suppose you want DSS. Okay, so let's have strain, which is having dot array, and the array is braces of bracket of, inside this we have, okay, let's say 1 2 3. We have 3 variable, input variable. Okay, and okay, what we can do, can combine it. No, so here only, because it is difficult to write it 1 2 3 4 5. No, no, let us keep it that way. Strain number. Okay, say 1. Okay, strain 2. There is 2 2 pattern yanta, pattern fixing system 2 4 5 5 3 4 5. Mhm. Okay. 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 So first thing I need to make is extrain. Capital extrain. Okay. To combine this multiple arrays into one. 1 by not sure it will work or not. Then we have W and B that we need to define. We'll define it as a 0. Okay. We'll get the shape. First it should work, then we'll get the shape. And with the same shape, we have to put it zeros. Okay. And then we are going to use it, the weights and everything. Storing things takes some time. So, all these basic things so that there should not be any doubt. Okay. And what is used to print? Is there anything? Print. Let's see. No? Any mind? I'm just They give some good models, man. I don't know which model. Some old model. But to put a lot of brain, let them put. Let's see. There is it's not able to do. So now it looks this way, huh? Okay. Now what we want. So we have a training data 1, 2, 3. This is first set of training data. Three variables x1, x2, x3. And then second set 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16. So what we should have, we want z. Okay. Now what we want, we got the shape, we got the data. What we want to calculate z. Is it? Then we will go for sigmoid function, that is we keep it the name as a, or y cap we put as a, or that is the output that will be generated by this. Okay, so z. what I have is W1 will change its sample. I know is W1 will change, but here we are not doing that because we want to update it in each iteration, so we just want to be some value. Okay, okay. So what we have this. Now what we want, select, we want output, okay. Okay, now again I need to put. Now we have something called, this is basic things. Okay, now what we have to find cost function. First thing you should remember, it should be not just, let's keep it one. Now what we have something called, we have got a loss. column. Okay. Main party is still left out. Cost and loss is fine. It is a differentiation. So tell me what is the differentiation? This we got now. We wrote in the notes also. Think for this updation. Let's keep it here. Let's solve the assignment. Yes, a new round. We'll close it for now. We'll see it tomorrow. Thanks.